Hello guys, welcome back. This is part 2 of the notes from August 15th and August 16th. I'm going to go ahead and show you guys a visual representation of the sets that we just talked about. We did set A, set B in example 1 and example 2. Then example 3 was set C. I kind of just let you guys create your own set. And then I went ahead and I started with set D. And then set D became the subset of A. And now I did set F, which allowed set A to become the subset of D. Okay? Now I'm going to go ahead and show you guys a Venn diagram or a visual representation of how these sets look like in a picture. I'm going to go ahead and start with set A. So over here, I'm going to draw a circle. I'm going to call it A. And inside of that circle, we're going to go ahead and describe the elements, which are the 0s through 9. But we're going to do that in a little bit because we know that some of those elements are also being shared with B, with D, and with F. So I'm going to go ahead and draw how these circles are going to look like, and then we'll fill in the elements in the end. Let's go look at B. B has elements 2, 4, 6, 8, 10. Out of all these elements, we know that 2, 4, 6, and 8 are being shared with A. They're right here, 2, 4, 6, 8. So we know that in the picture, B will intersect with A, but not completely, because B has an element that is not in A. Therefore, this element will be outside of A. So I'm going to draw a circle right here. We'll call that B. That's set A, set B. Now let's look at set D. Set D has elements 1, 2, 3. And we had described in the notes in the previous video that set D is a subset of A. Because it's a subset of A, in a picture form, it should be inside of A. It should not be outside. So I'm going to go ahead and draw a circle inside A, but I have to consider if any of those elements in D are going to be shared with B. And it looks like the number 2. The element number 2 are going to be shared with. So that means that B and D are going to collide. So I'm going to draw a circle right here. Call that D. Okay? And then finally we have F. F consists of pretty much all the elements that are being described in all the other sets. So F happens to be called what we call here in math the universal set. Hey, what's going on, Coach?
Cool, I'm watching.
Yeah.
I was doing it real quiet, I didn't want to wait.
So here we have the universal set F. F consists of all the elements. So we're going to go ahead and box this Venn diagram here. And we're going to call this F. And again, this is called your universal set. And what the universal set is, it just contains all the elements that we're talking about in the example here. Okay, so now we're ready to start implementing the elements into this visual representation. We're going to start with the smallest one, preferably the one that gets shared the most. What element is being shared between all 4 sets? Well, if we look here, looking at the smallest one, it looks like the number 2 is the one that's being shared the most. 2, 2, 2, 2. So I'm going to go ahead and write the 2 right here in the very middle. Okay, so the 2 we've already used. We don't need to see it anymore. Okay, continuing looking at D, right? D only has elements 1 and 3. That's what's left in set D. So I'm going to go ahead and write it right here. Set D, 1 and 3. So 1 and 3 are used. We can cross those out. 1 and 3, 1 and 3, 1 and 3. Okay, looking at set B now. Set B had an element that was outside of A. So what element was that? That was element 10. Number 10, right? Number 10 was not being shared in A. All the other ones were. So I'm going to cross out number 10 and I'm going to write it over here. And then set B also had elements that were being shared with A. So those elements are right here. The 4, 6, 8. Cross those out. The 4, the 6, and the 8. So I can cross those out down here. 4, 6, 8, and then the 10. So right here we have 4, 6, and 8. Okay, so now let's look at what elements are remaining in A, because that's what's left here. Over here we have a 0, a 5, a 7, and a 9. 0, 5, 7, 9. And again, let's cross out the ones that we've already used from F. 0, 5, 7, 9. It looks like we've already used all the elements in F. If we would have had the -1, let me go ahead and put the -1 that we had here, the one that from the previous video. If I had a -1 in set F and it didn't get crossed out with any other set, then that negative 1 would just belong somewhere in set F on the outside. Anywhere here, just negative 1. Because that element is not found within these other sets. This is it, guys. This is how you do a visual representation of your sets that you're working with. Thank you.